Okay, so we will do this second part of this question of concepts of physics, and the reason I am hoping that you are here is because of the second part of this question. Assuming, of course, that you have read the question, this is the answer that we get, that the current is N1E divided by N1 upon N2 times small r plus capital R. So this is the current we get, if I'm not wrong. We'll see if I'm wrong. So now we have to find that for what relation this is maximum, and this here actually it's a bit tricky question. I tried to do it. I mean, the only thing is if you know this, then you can easily do it. But you know that this is a constant. The problem is, I initially thought that when you vary n1 and n2, you can just vary it, like there is no restriction, because if n1 and n2 are not related, this problem becomes a problem of two variables. If n1 and n2 both are variables, then this becomes problem of two variables, and then minimizing I becomes very difficult. But once you know this idea that this n1 n2 is a constant, then this is a lot more doable. So now the problem actually converts into function of one variable. Either you write n1 as function of n2 or n2 as function. So let us just write let us write n1 as n2 capital N by n2. So n1 will become capital N by n2 times E, or we could have written n2 also. So let us do n2. Maybe that would be easier. N2 can be written as capital N by n1. So my I is n1e divided by n1r, and now I'm writing n2 as capital N by small n1. So it is capital N and then divide by small n1. So this becomes like this, right? And right now you just have to maximize it. So this should be 0, right? So apply this condition and the answer should come. Really, like, I struggled with this question for a day almost, because I forgot this condition, quite honestly, and I thought that this is a problem of two variables. Once you do this, the minimization becomes very easy and the answer will come like it should come. So try to do that. Just differentiate it, solve it. But yeah, I mean, the reason I wanted to make video on this is because the very first thing that I struggled with is there are n1 batteries. So if there are infinite batteries, then that could deliver infinite current, but then that would also provide almost infinite internal resistance. But then n2 could then be infinite, and n1 upon n2 then be an indeterminate form, and then that might give something finite, and those sort of thing. And then I tried to do it in various methods of calculus, which I was wondering that why would a question like this appear in class 12th book. But yeah, so thank you. I mean, I liked it. Try doing it. Okay.